Hello everyone, my name is Finding Pepper and I am back with episode 3 of the 3D Minecraft tutorial. This episode will be adding a player, which will involve coding collisions with blocks, gravity, and mouse-controlled camera movement. We're going to start off by making some variables to hold our player's position. I'll call them player X, player Y, and player Z for all sprites. I'll make a block called reset player, run without screen refresh, which I'll use to reset these variables at the start of the game. I'm going to take our set camera X, Y, and Z blocks out of the when flag clicked, because now we'll set those variables based on our player position. Change these to be player X, Y, and Z, and we can leave these values the same. Now we'll make a block for our player movement called move player. Run without screen refresh. I'll drop this block inside the forever loop before we move camera. I'll look in the move camera block, and I'll take out the change camera X, Y, and Z blocks, and move them into the move player block, changing the camera variables to player variables. Now in the move camera block, I'll set our camera X to player X, camera Y to player Y, and because our player is a bit tall and we want to be looking out the head, which is at the top of the player, I'll add 0.8 to this, which is slightly less than a full block. Now we can set camera Z to player Z. Let's run this and see if it works the same. And it appears to. We can still move around, go up and down, and look around. Now it's time to add collisions. Let's first take a look at how collisions will work before we begin to code them. So we have our beautifully drawn player here, and we have a block that the player is going to collide with. We can define points along the player's edge that will detect collision. If any of these points collide with a block, then the player has collided with a block. And we can use getBlockAt to find blocks at a given point. Now, once we've collided with a block, we want to be pushed out of the block. But how do we know what direction we want to get pushed out in? We could go up, down, left, or right. Well, we know we moved up and to the right, so when we pushed out, we want to go either to the left or down, like so. But we still don't know which of left and down it is. Rather than moving all at once, we can move in the different axes one at a time. So first, we'll move in one axis, and we haven't collided with anything here, so we don't need to move the player in that axis at all. Now we'll move in another axis. And here is where we've collided with something. So when we push the player out of the block, we want to do it in that axis, in the opposite direction that it moved, like so. Now let's try to figure out where we want to move the player out to, or rather how much we want to change the player position. We can think of the left and bottom of the blocks having x and y coordinates 0, and then the right and top sides of the blocks having x and y coordinates of 1. Let's say our player is at x, y within this block. We can find the x and y values within the block by performing modulo on the actual x and y coordinates. Now to get the amount that we change by, we subtract our current position from the target position. Now in this case, our target is just to the left of the block, and our current position is at x. So we'll move left by negative 0.01. That's just making sure we get all the way outside of the block, minus x. For moving right, our target becomes just to the right of the block, and we can use the same target minus current. And then same for the y value, and then in 3 dimensions, same for the z value. Alright, now that we've got this, we can begin coding. First of all, we'll need to know how much we move by each frame and in what direction, so if we collide with something, we know what side to move out to. We can repurpose our change x, y, and z variables. I'll set our first change player x to a set change x, and then we can change x by our second amount. So our change x is the sum of these two values. Now we will change our player x by change x. And I'm putting the two x's next to each other and the two z's next to each other because, as I mentioned, we'll need to do each direction separately. and all at once. Now we can do the same for the player Y. We'll set change Y to this value here that we changed player Y by, and then now we change player Y by change Y. Finally for the Z, set change Z, change Z, and change player Z by change Z. So now we're storing how much we changed by in each of the directions. Now let's make our collision block. We'll make a new block called handle player collisions at, then inputs x, y, z, then a text label in direction, and then inputs axis and dir. Axis will be x, y, or z, depending on which axis we're checking collision in. And then dir will be our change variables, so we'll check if that's either positive or negative. Run with that screen refresh. Now a lot of what we need is in our check collision at block. So I'll go into here and I'll just duplicate everything that is here and move it into our new check collision block. Now in this block we'll check for each of our different axes. If axis equals x, then if dir is less than 0, meaning we're moving in the negative direction, then we need to move out the opposite direction to the right side of the block. So we'll change player x by 1.01 just to the right of the block minus our x, and then we need to modulo by 1 to get the x coordinate within the block rather than the x coordinate in the entire world. Then in else we'll check if dir is greater than 0, in which case we'll change player x by negative 0.01 just to the left of the block minus our current position within the block. Then after this we can stop the script. Then if axis equals y, then we'll just change all the player x's to player y's. And the x's to y's. Okay, now if axis equals z, then we'll change everything to z's. Now we've got our collision block, we can use it in our move player block. So after we move in the x direction, we can handle player collisions at player x, player y, player z in direction x, and the dir will be change x. For the similar for the player y, but we'll make the direction y and change y. Then lastly for the z, change the y's to z's. Finally, back in the handle player collisions at block, I realized that here we're doing the collisions no matter what. Rather than checking if block is greater than 0 and then setting collided to 1, we're going to check if block equals 0, and if it is, stop the script. Now we can run this, but keep in mind that this will handle the collisions at the center of the player only. Let's try going down, and you'll see we cannot go down any further than this. If we run into the sides like so, again, we will collide with them. If we move further down, though, and try to go into the block, we can still go through. Our camera is situated a little bit above the center of our player, so that's why when we move down like so, our camera is still above the blocks. But anyway, let's go and get our width and height working. We'll make some variables, player width for the sprite only, player height, and player depth. Those will be the player's dimensions in the x, y, and z directions. We can set these blocks and reset player. These variables will represent half of the actual width, because that will make it easier for collisions. Mostly what we're using is half of those values. So in reset player, we'll set player width to 0.4, so double that is almost a full block. Set player height to 0.9, so double that is almost 2 blocks. Set player depth to 0.4 as well. We'll make a new block, handle all player collisions and direction, and then our same axis and dir inputs. And here we'll use the handle player collisions at block multiple times for each of the different points around the player. We'll get out one of these blocks and start with one of the corners. This corner will be at player x plus player width, player y plus player height, and player z plus player depth. For the direction inputs, we'll just use our axis and dir inputs to this block. So this is at the corner that is in the positive direction in all three axes. Now we can turn one of these to negative. I'll do the x1. Now I'm going to duplicate both of these blocks and change the y's to negative. So now we have all four corners in the positive z direction. Now we can duplicate this and get the four corners in the negative z direction as well by changing all the pluses here to minuses. So now we have all the corners, but we have one last set of collision points to do, and that is in the middle of the player up and down. Because the player is tall, then we'll actually end up being able to walk through blocks in some cases. So we'll duplicate some more of these blocks, separate these off so you can see them, and for the y input we'll just use the player y without adding anything to it. And we want all four combinations of positive and negative x and z. And then finally we'll just need to move our set collided to the empty value from our handle player collisions at block to our handle all player collisions. Because if any one of these registers a collision, we'll want our collided variable to be 1. So now we can use this block instead of using the handle player collisions at block in our move player block. So we'll handle all player collisions and just put in the direction and the change variable. Do the same for the y and the same for the z. And I realized I never actually put the reset player block anywhere. I'm sorry about that. If you haven't already, we should just put the reset player right before the forever loop. Okay, now we can run this, and when we collide with the blocks, you'll see that collision is working pretty well. We should be able to move up, and our head will be close to the bottom of the block, but not inside it. Yeah, our camera should never go inside the blocks. Awesome. Now we can add some gravity. Let's change our player spawn point to be over a block so we don't fall into the void as soon as we start. I'll set the player X and player Z to be over our first block, and player Y to be a bit in the air, like 2. We should just be able to look down and see that we're above a block. Alright, now let's do our gravity. So right now we're changing our Y by pressing our E and Q keys on the keyboard. But we want to be just moving downwards. Let's try, for now, setting change Y to -1. If we run this, we should be standing on top of the grass block. Then if we move off the edge, then we'll fall down. Yeah, we can make that a bit less, -0.1. Yeah, now we slowly glide down. But yeah, that's not real gravity. There's no acceleration, we're just falling at a constant rate. To make actual gravity, we're going to have to create a variable that gets stored across multiple frames. I'll call it speed y for this sprite only. Rather than setting change y to -0.1, I'll change speed y by -0.05. And around this, I'll also just make sure that our speed y is greater than -0.5, just to make sure we don't fall too fast. If we fall too fast, we might be able to fall through some blocks if we're falling at a high enough speed. Replace our change y variables here with our speed y variable. In reset player, we'll set speed y to 0. Now back in move player, after we handle our y collisions, we'll check if collided is greater than 0. And if it is, we've hit something, and so we set our speed y to 0. Note that we only do this with our y collisions, so if we hit something from the side, that won't erase our y speed. Let's run this. So now we're standing on a block. Then when we fall, you'll see that we speed up as we go down. Okay, but this isn't very fun if all we can do is just fall. Let's add some jumping. Before we change our player y, I'll check if key space pressed. If it is, we'll simply set speed y to 0.3. If we press the space key, then we should be able to jump. But we can jump anytime, not just when we're standing on a block. So let's change that. I'll make a variable called falling for this sprite only. That will hold if we're falling. It will be 0 if we're not falling. in Move Player when we check if collided is greater than 0 when we handle our collisions? Well, if we're moving downwards when we collide, so if speed y is less than 0, then we've fallen down onto something, or in other words, we're standing on something. So we'll set falling to 0. In the else condition, if speed y is greater or equal to 0, then we've hit our head on something. So we'll set falling to a large number like 99. I'll make our if collided is greater than 0 into an else. In the else, if we're not colliding with something, we'll change falling by 1. So every frame that we don't collide with something in the vertical direction, we increase our falling variable. Now around our if key space pressed, I'll check if falling is less than 3. I'm checking if it's less than 3 here rather than if it's equal to 0 because this can give us some variation with our jumps. If we hold space for longer, we can jump higher. You can change this number to something different if you want, as with all these numbers. Now we can only jump when we are standing on something. Now there's one last thing I'd like to add in the realm of player movement, and that's falling into the void and respawning. In our main loop under when flag clicked, we can simply check if player y is less than, say, -5. If it is, we'll reset player. It's as simple as that. So run this and fall off the edge of the block, and then, yep, we're right back here. Awesome. Now the next thing to add is mouse-controlled camera movement. So when we move the mouse, that will change what direction we're looking. Now we'll need to get the change in our new mouse position from our previous mouse position to tell how much we need to move the camera. So to do this, we'll need to make a variable, actually two, prev mouse x for this sprite only, and prev mouse y, stands for previous. Okay. Now at the end of move camera, we can set our previous variables to our mouse x and mouse y. Then rather than changing by our arrow keys, we can change by the difference in mouse x and our previous mouse x. And then same for the vertical rotation. Let's run this. And now when we move the mouse around, we will look in different directions. Awesome, that's looking great. Now there is one issue though. If I move my mouse off screen, I can no longer turn anymore in that direction. We can say if mouse x is greater than like 220, so that's on the right of the screen, we'll change our horizontal rotation by say 5. And in the else, we can check if it's less than -220, and then change the rotation by -5. And then we do the same for the y and the vertical rotation, and then we'll change the 220s to like 165 and -165 because, you know, the screen is less tall in that direction. So now if I put my mouse on the left of the screen, we just turn. Okay, this is looking pretty good. We have a little bit of time left, so I suppose I might add a fade effect to blocks when they get far away from the camera. I kind of meant to do this last episode with the textures, but I didn't get around to it. So we'll need to add a 5th item to the view list to hold this. So we'll set our data mount per view pixel to 5. Now let's get an if-else statement. We can use our dist variable to tell how far away we are from the camera. If dist is greater than 0.75 times view distance, then we'll want to do some stuff with transparency. But otherwise, we'll just add a 0 to view for the 5th item. Now, if we are beyond 3/4 of the way to our view distance, we want to have some transparency. So first, we'll subtract this 0.75 times view distance from our dist variable. So if our dist is equal to this value, then it would be 0. So that gets our range to be starting at 0. Now we can divide this by the remaining distance, which is 0.25, to get the percentage of the way the dist variable is from this 0.75 times view distance to the end of our view distance. Then we multiply by 100 all the way at the edge of our view distance is 100 transparency. Now in our display view, set pen transparency to item I plus 4 of view. Run this, and you can see that things fade out as they become far away. Just like that. Nice. Alright. That's looking pretty good, I think. I think it's a good place to end this episode, because we've done a lot of good stuff today. Our game is now more of a working game. You could totally turn this into some sort of platformer if you wanted to, rather than a Minecraft game. You could upload your own textures rather than the ones I have here. And I encourage you to do so, if that's something that sounds fun to you. Anyway, I hope you enjoyed this episode. Have a great rest of your day, and goodbye!